Okay, so I have 8 o'clock. Let's begin. Everybody hearing me? Yes?
Yes, sir.
All right. So the class will be recorded and it'll be posted up on the e-classroom. So for those who might be a little challenged in terms of joining, they'll be able to review. So a pleasant good morning, everyone. Welcome to Biology 172, Structure and Function of the Human Body, Part 2, CRN 21155. I'm delighted to be your instructor, your lecturer for this semester. My name is Dr. Patrick Campbell, and in terms of introduction, I have a BS in biology from Morehouse College in Atlanta. And after that, I went on to Morehouse School of Medicine, where I did my PhD in the biomedical sciences, doing specific research in the area of immunology, particularly in HIV. And after that, I was over there in the cold, and then Costa picked up the phone and gave me a call. I was delighted to come back home. Notwithstanding that, what do I like to do? I like to listen to cricket. Football, cricket is be stressful, but enjoyable none the same. In terms of cricket, for those who are following, I like to follow the West Indies. And kudos to the women who won their last game. You know, it was a nail biter who they play. I want to say Bangladesh. And they won by 4 runs. Prior to that, they won very close scores with New Zealand as well, you know, and England, winning in the last over in both cases. So it's always good. You gotta love them. Right now, the men, they're playing England, and they're playing England, and they're doing pretty well. So all in all, I just like to follow cricket and sports in general. While I was at school, I did play sports, you know, cricket, football. I represented the school at both of them. I also played pan as well when I was in school, tenor pan, and I was also a bit in the choir. So yeah, I think I enjoyed life while I was at school. All right, so enough about me. Let's see if you could go around the class now, and if you would just introduce yourself. In terms of introduction, what you'll do is just say your name, where you're from. It could be general area. You don't have to be specific, north, south, east, or west. Right? So just say your name, where you're from, something you like to do that is not illegal, immoral, or fattening. All right? So let's start. Go ahead, Jonathan. Now, Mark, you if you're feeling a little intimidated in terms of speaking, you don't have to. So I wouldn't be mad with you if you don't introduce yourself. All right, let's start. Maybe we could do it in alphabetical order. Let me just pull up the roll. Let me see, Alexis. Alexis, you.
Good morning.
Mhm.
Hi, my name is Alexis Barron. I'm from Princeton. In terms of hobby and stuff, I like to read and do nail art.
Ah, you like to read a lot. What was the last good book you read, Alexis?
A book by Colleen Hoover. It Ends With Us. That was a good book.
It sounds good. That's nice, man. But yeah, reading is always a good pastime. Thanks very much. Aaliyah?
Hi, good morning, everyone. My name is Aliyah Leacock. I'm from Superior, and I like doing balloon decoration.
Oh, balloon decoration. That sounds good. Yeah, I saw plenty colors and so on. Thanks a lot, Aaliyah. Amira? Amira probably stepped out for a cup of tea. We'll come back to her.
Oh
And
no, I'm here,
oh,
sir.
oh, okay,
I'm
go ahead.
here.
Go ahead, go
But the
ahead.
Wi-Fi dropped, so I didn't hear
I
my name.
understand.
Sorry about that.
It's all good. It's all good.
Yeah. Okay. So good morning, everyone. Good morning, sir. My name is Amira Hussein. I am from Princeton as well. And the only thing I really like to do is, like sit down and watch series upon series on Netflix until I can't really finish one.
Yes, which ones you like, Game of Thrones or some of the others?
Well, right now I'm watching The Walking Dead, and it's like
Mm,
science fiction. So it's going good.
Yeah, walking that off with rather
Yeah.
interesting. Quite so.
Yeah.
Yeah. Great. Thanks a lot. Okay. That was Amira. Anessa. Anessa stepped out for a cup of tea. That's not a problem. Let's now look at, and that was Anessa. I didn't specify which one. Anessa Williams. So let's look at Bina. Bina, you there? If you would just introduce yourself, name, where
Hi,
you're
morning,
from.
sir. Hi, morning all, morning, sir. From the Pianco area, Urban Gardens. I like drawing and going to the movies, but recently I'm more in the kitchen area now. So I spend most of my time cooking now.
What you saying?
Yeah, you try to come up with recipes, so I'm so grateful for all these YouTube videos. You can try different recipes.
Yeah, it has so many. What?
Yeah, but
if so, go ahead.
But one of my thing is baking bread. I'm more like the baking aspects, more like the baking bread, the pizza, because I have a 15-year-old son. So, you have a lot of cooking there.
Yes. And it's a good thing you're doing with bread in particular, without kiss making style these days.
Yes,
So
different kinds. So I'm experimenting. I try different things, like little tuna pies and different stuff like that. Yes, so I'm
That's
putting my
very
foot into the cooking area now.
okay. That's very good, Bina. Most definitely.
All right, thank you.
All right. Thanks for sharing. All right. So that was Bina. So Chanel, if you would, by means of introduction, name, where you're from, general area, and something you like to do that is not illegal, immoral, or fattening. Go ahead, Chanel.
Hi, good morning, everyone.
Good
You all
morning.
hearing me?
Clear as a whistle.
Hi, good morning, sir. Well, I'm Chanel James. I'm from Pity Valley in the West. Currently 32 years of age. What I like doing is looking at a lot of exercising videos. It tends to attract me a lot, keeping your body healthy. And that's, is just what piques my interest most of the days, the body functions and stuff like that.
Well, in the right area, Faith. You like watching or participating? Which one? Or you
Well,
get into the
both,
participation
actually.
point? Gotcha.
Yes.
That is nice. Thanks a lot.
Yes.
Thanks for telling us that,
Welcome.
Chanel.
Bye.
Okay. All right. So let's see. Charles, you there? Remember you're from SNF1.
Yes, sir. I'm here, all the way in Tobago again. Still, I realizing that I like a lot of things because I listen to everybody. So I don't know where to begin, but I like to eat, and I'm trying to make healthier choices.
Maybe. Go ahead.
Okay. I'll leave it there.
I was not going to say maybe you could start with some nice healthy breads, and I know somebody who I could refer you to. That
I make my own bread, and I do
what
try
you
to make
saying?
it. Yeah, I make my own bread, and I could bake a little sweet bread, I could make a little cake.
What you saying?
I do my own cooking, so I do put the butters and the heavy seasonings. I'm really trying, yeah.
Excellent, man. Okay, that is good. I was going to tell you about Bina, who like to cook bacon and so on.
Excuse me, I'm going to say the same thing. We had to swap recipes.
Yeah, but so you might maybe get busted for Bina, you could never know.
True. Getting in trouble, but point you in trouble. Point taken.
It's early morning for this.
Quite so. Thanks a lot, Charles. All right, Danielle, if you would.
Also, good morning. I apologize that my name is Daniel. I keep having this problem. I'm using my son's laptop and it comes on as Daniel.
Okay, my bad. Okay, Daniel, go ahead.
So my name is Janelle Smith. Morning, everybody. So you would have had me in SNF 1. My likes are, well, I know it's nothing fattening, but I like to sleep, eat, and watch TV.
I ain't mad at you at all.
And well, seeing as you already betrothed Charles to Bina, I was going to ask him, Charles, you're looking for a wife, seeing as you could cook, clean, do everything.
What a thing, what a
We
thing.
have
Look
to
at trouble.
consult screening on that, okay?
You have to go through the screening process, quite so, quite so. Look at trouble.
Yes, and I
Saturday
remember you
morning.
guys from, yes, I remember all of you guys from SNF1. So
That is grand.
Nice.
That is good. That is good. But yeah, but having somebody, who could cook and so on, that is very important, particularly now when, in terms of the spillout from those issues happening with both Russia and Ukraine. Ukraine is about, I want to say, the second largest producer of wheat. And right now, because of the fact, they under, with this war with Russia, all the fields and so on going uncared for. And for those of us who are familiar, well, you're probably well aware, wheat is really a grass, just like sugar cane. And if it's not cared for, it becomes unharvestable. I don't know if that's a word, but you can't harvest it. And that's one of the issues currently with Ukraine is speaking about that. So notwithstanding, even if they do find a solution to that issue over there, we would have a problem with wheat going forward, right? Because most of the wheat they supply goes to both Europe and Africa. And if they do run the deficit, well, of course, US wheat will be going across there, which will mean less for us. So another thing, what we should be looking into is, alternatives for wheat flour. I remember reading about 3 or 4 weeks ago, there's this guy who's doing research in terms of making flour from piwa. It was in the Express or the Guardian. I don't know if anybody saw it. He's either at UTT or UE, and he's looking into that. So, there are other sources in terms of making flour. So, in terms of it, maybe that's something that, both Charles and Bina and all those other bakers.
Yeah, but so that type of flour kind of powdery, like the cassava and oats. So you had to, it's a different recipe you need. You need a more batter type.
Cassava,
so
you must mention in that.
You gotta be careful with that, because you won't get bread or get something else.
True. So I suppose in terms of doing a bit of experimentation in that regard, in terms of using those different types of flour. And who knows, keep your eye out for the piwa flour. That sounded very interesting, or maybe you could try making it yourself. I don't think you do a little research in terms of how flour is made, in terms of, let's say things like cassava or arrowroot. Arrowroot. Well, we don't. St. Vincent is big on arrowroot, and then maybe you could do your own little experimentation. I know PY expensive, so that mightn't be the best things to experiment with. Cassava is pretty good in terms of costing, so maybe you could look at cassava. Just a thought. All right. Okay, great. Thanks a lot for sharing. So who's next? That was who just spoke there? Crystal, that was you. Janelle just finished. Okay, so Jonathan, if you would, do a little introduction, please. All right, so Jonathan just stepped out for a cup of tea. Not an issue. Kiran?
To Karan, sir?
Yes,
Morning.
my bad. I apologize. Go ahead, Karan.
Morning, sir. Morning, everybody. My name is Karan. I'm from Laventille. I am pursuing nursing, and my hobby, I like to play games.
Electronic or mind?
Electronics and mind. Both.
I hear you. I suppose it's an overlap, because when you do look at electronic, you could seep in. What type of electronic games you like to do? Like mazes or fighting or first person, or which type of games you like?
All in a matter of fact.
That's good, man. That's good. It's a nice way, to keep your attention and really, focus. Yeah. So that's good.
I like the challenge too.
Quite so. I am mad with you. Thanks a lot. All right. So who's next? After Jonathan, whom we have oh no, that was Karan. Sorry. Kadisha.
Hi, good morning, everyone.
Good morning.
My name is Kadisha Daniel. I was in SNF1 with you, sir. Not sure if you remember me.
I remember you. Yes, yes.
music being a huge part of my family, it came naturally.
Really? What you always do? Parang, have your own group,
My
sing,
my dad is actually the arranger for Desperados,
What you
Calvin
saying?
Drama.
What you saying? Oh, watching your slide, man. I didn't know that. Wow, that's fantastic. That is so complicated. You know, oftentimes we
Yes.
talk about people like, you know, Johann Sebastian Bach and all of them, you know, from Europe. And we look at it's the same thing that what they do in terms of pan arrangers. That's exactly what he's doing,
Yeah.
arranging an orchestra. That is
Yeah.
fantastic. Go ahead.
Yeah. So with music being a huge part, I naturally fell in love with it. Fell in love with I love to sing, love to dance, love pan. Love pan. So that
Yeah.
is
This year
when
had any, if I could cut across it, this year had any panorama of any type? I was kind
it
of out of the
had
loop.
a small little competition, but nothing to talk about, like,
Not the real
yeah, not
deal.
a
Oh,
small thing.
you're missing it. You're
Yeah.
missing it, eh? You're missing the savannah.
Yeah.
Oh gosh,
Most
yeah.
times I watch my dad and he like, I just feel it for him.
I hear you. I hear you.
Yeah.
Yes. Well, soon let's look at 23. Fingers crossed on
Yeah, I hope
23
so. I
that
really
things
need
come
to
back.
go in that savannah.
So 23, we're looking for good things to happen. Yeah?
Yeah.
Okay, great. All right, thanks a lot. All right. So who's next? Let's see. That was Kadisha. Sophia.
Hi, good morning, sir.
Good morning.
I'm from the San Fernando area. Well, I kind of boring, but I like to play instruments.
I know somebody who is play pan who I can recommend you to. Go ahead.
It's like I recently started picking up the bass. So I'm
Bass
trying
guitar?
to, yeah. So I'm trying to put my knowledge on that. And I know a little one or two things on the keyboard. So
What you saying? That's good, man. Yeah,
yeah.
could you read music or you do it by ear?
Oh God, yeah.
That is fantastic.
I can't read music to save my life.
I hear you. I'm mad. A lot of the great composers and musicians, most of them couldn't even read music and they did it by ear. So I'm not mad at you at all. That is really good. And keep it up, okay?
Yes, I will. Thank you.
Okay. Thank you. Swan.
Hi, good morning, sir, and everyone. I am from the Granville area. I attend the South Campus, and I like going to the beach and spending time with my family.
What is saying? Salt water good for you, particularly in these times? You know, nothing better than that salt water. The more the merrier, whenever you could go and soak. And notwithstanding that the viruses don't like salt water at all. So that is one. It's
I live in close to the beach, just 10 minutes away.
You're making joke. What you're saying? So yeah, well, I suppose I'm preaching to the choir, as they say. You know about the benefits of salt water and going to the beach. And sometimes even if you're feeling to be, just go by the beach and sit down. Right? That salt water is phenomenal in terms of health, for your health. So, you know, I'm jealous here because similarly, I like the beach. But I live a little distance away. I have to plan a trip to go there. So good for you. And, you know, just keep on keeping up with the beach and so on. Good. Thank you very much. Tanisha.
Hi, good morning, everyone. So my name is Tanisha Gordon. I'm from the South area. I do apologize for how I'm sounding. I'm a bit unwell, so I don't really have much to say.
COVID?
No, I just came home from
Knock
work
on wood.
yesterday.
Knock on wood. Okay, a little sore throat.
Yeah,
these days,
thing.
these days that's a buzzword. I myself had a bit of COVID, yes. So and I just had to go over it. How it affected me, it affected my stomach. You know, and notwithstanding the weakness, I didn't get it in any, I suppose, extreme means. It affected my stomach and couldn't eat much at all. It was only soup for a while, yeah. Anyhow, I digress. Please go ahead.
Yes. So my hobbies are reading and I like to listen to music. I have a lot of animals, as you can hear in the background.
What you saying? What kind of animals you have?
I have 2 parrots. I have about 4 dogs in my yard, and my backyard is full of rabbits as well.
What you saying? That's good. Do you find that animals naturally gravitate towards you when you see them? Like if you're walking in the street and it have a dog, you know how sometimes you just see dogs at the back at people for no reason?
Sometimes some dogs don't like me. I don't know why, but I like small puppies, like small dogs. I don't like big dogs at all.
Right. That is good. All right, great. Thanks very much for sharing that with us. All right, so who was that? So Tanisha? Okay, Tanisha stepped out for a cup of tea. Not a problem. Is there anybody that didn't go who would like to just introduce themselves? As I mentioned, if you're not feeling update, it's not an issue. Other than that, in terms of introduction, just say your name, where you're from, and something you like to do that is not illegal, immoral, or fattening. Crystal, go ahead.
I think someone was speaking before me. I'm not sure if that person changed their mind.
Go ahead. When you finish, I'll go.
Okay, no problem. Well, my name is Crystal. I'm a second semester nursing student. My main interest is in looking for healthier options in terms of eating. So as you all were talking about gluten-free, I've been doing gluten-free for about maybe 3 years now. So
what advantages you've seen in terms of you being gluten-free? Have you seen any changes?
Definitely in terms of my digestive issues, and in terms of, well, female sort of issues, because you know, with gluten and the glycemic index, and even with gluten-free flours, you have to be careful with that, because things like cassava, those are high on the glycemic index, and white rice and stuff like that. So you have to really be able to combine your gluten-free flours to ensure that they give you the best option health-wise.
That's grand. Well, very good that you're eating healthy, and also for sharing that very important information as it relates to gluten. Thanks very much, Crystal. All right.
Thank you.
And who's next? Was it somebody we missed just now? Was it Angeline? Okay, maybe they just stepped out. Anybody else would like to, who hasn't done so, would like to just introduce themselves? Go ahead.
Yes, morning.
Morning, go ahead.
Can you hear me?
We surely are. Angeline, go ahead.
Okay, good. Morning, sir. Morning, class. My name is Angeline Palmesa. I live at Niaru. I was at Sandy Grande campus, but now I'm relocated to Chagones. I love bathing on the beach. And I have a 2-year-old daughter who loves water. So any chance we get and sun come out and I in her class, it's beach we going.
I hear you. Once again, I'm jealous here in terms of being by the beach, salt water and all of that. Like as I said, it is excellent.
Yeah, and I live like a stone throw away from the beach, so it's real convenient.
That is great. Excellent. I'm glad to know that, Angeline.
Looking forward to learning plenty from this class. You're never too old to learn something.
Oh, definitely. Yeah, most definitely. Until you cross the threshold and speaking with the ancestors, you can always continue to learn. So that is very true.
This class looks exciting. So I have good hopes for this class.
Feeling is mutual. Very good for you in terms of going forward, most definitely. And by doing so, I'm sure your daughter, will be very proud of mommy. Excellent. All right.
Thank you, sir. All right.
Anybody else who didn't introduce themselves? If they would like to.
Yes, sir.
Go ahead, Kimberlee.
Yes, my name is Kimberlee. I am this would actually be like my third calendar year, because I had to do the campus courses first. So yeah, and my hobbies would be like listening to music. I actually really like to read. So yeah, I read a lot of books. I think last year I read like about 120, I
Wow,
want to say.
wow. That's more than a lot. Wow. That's phenomenal, man. Yes, yes, yes.
Yeah, and that's really all. Well, besides class, that's what would take up my time.
That is really good. But yeah, so what do you think you get from reading books? Why the attraction in terms of reading books for you? Any particular reason you like to read books?
Um, mm, I I don't know. It's just be fun. I mean, like I saw this thing on Instagram where they were saying reading like a book is just 52 letters rearranged a million different ways,
I like that.
and
Yes.
and somehow it is just be fun and take you to different worlds and stuff. So
Quite so, quite so. It transforms, it
yeah,
moves you from A to B. You could be at
yeah,
different scenarios, and you could do that without going anywhere. Yes, quite so.
yeah.
So I could understand
Especially with the lockdown and stuff. I felt like I read more with the lockdown
oh,
because it
yes,
had
yes,
really
yes.
nowhere to go, nothing to do besides read. Yeah,
That is
so
so true.
yeah, that's it about me.
Okay, thanks very much. No problem. All right. Anybody else didn't introduce themselves and would like to do so? Like I said, if today you're probably not feeling update, is not mandatory. So any other introductions for persons who haven't introduced themselves thus far?
Good morning, sir.
Good morning.
This is Lisa, and I want to say it's a pleasure doing this class with you again.
What you're saying?
I was wondering if you have any other classes you do in school other than SNF, so I could join.
I also teach immunology, but that's a level 4 course, yeah. So
Yeah, I will take that.
yeah, so immunology. I don't know if they might switch me on to any others, but SNF, I might do some microbiology as well. I've taught it before, microbiology for nursing. So you can look at me there, SNF, microbiology, and immunology. Yeah.
Immunology.
Yeah, dealing with the immune system. That is really my area of research. Yeah.
Yeah. Well, I but taxonomy. I love sightseeing, which I love to travel. I love to learn new places and history of new places. I enjoy.
Okay, that's good. Yeah, yeah. I suppose, well, COVID restricted us in terms of physically traveling abroad for quite a bit. And even when we were on a bit of lockdown, it did restrict our movements and so on. Yeah, so, but that's good. Up Claxon Bay there, it have fish. And people is fish and it have fish
Yes,
right
sir.
there.
Always.
Yeah, they
Yes,
sell
I live
fish.
close to the market.
Yeah, I must come down there. I currently staying with my mother in San Fernando. I must come across the Claxon Bay and pick up some fish. Because sometimes when you go on the wharf, for some odd reason, yeah, they don't have fish every day. And what they do sometimes have it on ice. I want to sell it to you. How you know a fish fresh? Let me hear you. How you know a fish fresh?
It don't smell. It don't give a high.
Smell, yeah. And you look in the eyes. When it started getting, it get cloudy.
Pineapple, yes.
Correct, yeah. And when you push on it, when it's fresh, the skin is bounced back.
Yes.
But if you juke it and you see it leave the juke in the fish, it stay down. Yeah, that's another way, something a little wrong there. I must do that since we're feeling for our broth today. We'll see what will happen. Thanks a lot for sharing. Thanks very much. All right. Did we leave out anybody else who'd like to introduce themselves, his or herself? In terms of just saying your name, where you're from, something you like to do that is not illegal immoral. Okay, great. So I think we've gotten everybody. So before progressing, let me just quickly call roll and then we go forward, okay? So let's go. Alexis.
Present, sir.
Alicia.
Yes, sir.
Okay, no problem. Aliyah,
Yes, sir.
Amira,
Present, sir.
Anessa,
Good
Angeline.
morning, President, please. I'm here.
Okay, Anessa, thank you. Angeline. I know Angeline was here. Yes, Ariel. Ariel stepped out for a cup of tea. Bina.
Present, sir.
Brittany. Stepped out for a cup of tea. Chanel.
Present, sir.
Charles. I know Charles is there. Crystal.
Present, sir.
Ernest. Ernest stepped out for a cup of tea. Janelle.
Present, sir.
Judith. Yeah, see, there's a C, isn't it?
Present, sir. Judith, present.
Okay, great. Kiran.
Yes, sir.
Kadisha. I know Kadisha is there. Kimberlee.
Here.
Lenicia. Stepped out for a cup of tea. Natasha. Stepped out for a cup of tea. Risa.
Present, sir.
Sophia.
Present, sir.
Chanel.
Present.
Stacy. Stacy stepped out for a cup of tea. Suan.
Present, sir.
Tanisha.
Present, sir.
And Valine. Valine stepped out for a cup of tea. All right, great. So, good morning, everyone, again. Today's class will be a bit short in terms of the introductory class. Don't want to burn out everybody on the first day. So, earlier this week, you would have received the well, you would have seen, in terms of registration, you would have had access to the class page as shown. Anybody did not have or doesn't currently have access to this class page? Just give me a holler. Great, so everybody has access to it. Let's have a look at it and see what's going on. All right, so here we see structure and function, Dr. Patrick Campbell. I kindly ask when you do address me as either Dr. Campbell or Sir, right? Not Mr. All right, Mr. was my father, and I do think you had the pleasure of meeting him. All right, notwithstanding that, in terms of in the educational sphere, do remember that you do have to address people by their correct titles. If you meet me outside, you could call me whatever you want. I wouldn't have an issue with it. But just within the educational framework, within COSTAT, within the classroom, do address me accordingly. All right. So here we see welcome to the class. The announcements will be posted here. And when you come down, the academic calendar is shown here as well. So do have a look at it. Now, the view you're seeing here, this is my view. Let me switch it up so that you'll see how to see it from your perspective. And as a teacher view, which is a little different from the so there's the view you all would have, right? So the calendar, very important one, the course outline, this gives everything that is required of you as it relates to the course. So if you want to get in terms of specificity for the different chapters and so on, when you look through, you would see it. All right. So if you come down, for instance, today we'll be touching on the first thing, unit blood. It has the content and the specific objectives, that which you need to know for blood. All right. So this is where you'd find the key things which are required of you as it relates to the topic. Yeah. Down here is the weekly schedule and important dates. This is something that you should have a look at because it tells you specifically what we're doing every week until the end of semester. So for instance, this week is all about blood. Next week, we're going to look at the heart. Week after that, blood vessels, lymphatic, and so on. So it goes through all the topics right? Digestive, metabolism, urinary, reproductive, development, and so on. Go show all the topics, and it tells you when the assessments are and when different dates are, so that you know and keep on top of it as it relates to submission of assignments. So I would want to say most definitely do have a look at this one. It is very important for you in terms of keeping abreast of what is happening in the class. All right, so do keep this one in mind, particularly there's a weekly schedule and important dates. Zoom link. Anybody had any trouble with the Zoom links this morning?
No, sir.
Okay, great. So you have to either
Yes,
click on it.
I wasn't getting through with it.
Which one is that? Who's that one?
The one
What's
you
the
have
one?
in the, yes, I
Which
had
one?
problems getting it this morning.
Which one was it giving trouble? This one or this one? You realize
Yeah, the
too?
first one.
This one was giving trouble?
Yeah.
All right, I'll remove it then. But when you click down here, you got through.
Yeah.
All right, so this one was giving trouble. All right, so I'll remove it.
Sir, you can leave it out because the first one I get through.
The first one you get through. So maybe
Yeah.
maybe sometimes, Zoom when they have a high traffic on it, sometimes it gives a little bubble. So I would leave it for this week. If next week we still having that issue, then it will be addressed. All right. So we just give it another week. I do know sometime, but you just click on the link and it carries you to the class. Should have asked you what time was it before 8 o'clock? Like as in like 7:15? Because I turned it on, quote unquote. I opened the class at about 25 to 8. So I don't know if you had logged on before, you wouldn't be able to get in.
No, so 8 o'clock self, I was
Oh,
trying
8
to log
o'clock
on.
self. Okay. So we look at that next week again. But if you, we look at it next week as well and see if there is an issue. All right. Okay. But it seems only you had an issue. Anybody else had an issue in terms of the Zoom class?
Yes, sir, I had issues getting in as well.
Natasha, and what was your problem?
Yeah.
What was the issue?
Well, I wasn't hearing anything. I get in actually, but I wasn't hearing or seeing anything for a while. And now that I log in from a phone, I'm able to see and hear. So I don't know.
So sometimes you blame it on technology in terms of that. Sometimes it do funny things sometimes. So we just leave it till next week. So other than those two, anybody else?
So for me, the first two times.
Okay. Pardon?
The first two times I didn't get through, but when I tried that third time, I got through with it.
Okay, Aliyah, thanks. Anybody else had trouble? Yes, who's logging in? Okay, so maybe we'll just throw it to the fact maybe Zoom was having issues as well. So we leave it till next week. It seems that the majority, in terms of the 23 persons signed in, 3 have issues. So we bat in 20 out of 23. That's a good percentage in terms of the numbers. So we'll leave it at that and we'll look at it. We'll review again next week if you're having issues, okay? Okay, so the weekly schedule, important dates, right? And this is what you would see now for the entire semester as you go along. The week and the activities will pop up. All right. So this week is the blood, and for each week, what you should do is just read. It tells you what is expected of you for the week. So, for instance, here under what students must do, I should change that word must. It sounds a little bit harsh. Right? But review the lecture on PowerPoint. One of the things you would see, all the lectures have been posted, will be posted, previous lectures, right? So for instance, I don't know, anybody look at the lecture for today? If anybody looked at it, but all you have to do, right, so all you have to do is click on the word. So when you say review the lecture on PowerPoint, you click on the word lecture and you would see the lecture come up, right? It's a YouTube lecture. Well, not YouTube lecture, sorry. It's a lecture saved in YouTube, right? So it would just come up and you can review it. Yep, so that's me, right?
So you wouldn't believe I did
just
not
click
even see that word lecture there.
No, yeah, that's why I pulled up the e-classroom. Yeah, Because sometimes it's right there, yeah, you miss it. I hear you. It happens to me as well. That's why I decided to go through. So in terms of ease, we just put the words so you could just click on it. So click on the word lecture, the lecture will come up. Click on PowerPoint, the PowerPoint comes up as well. Click on resources. So notice it says here, review the lecture on PowerPoint. So lecture PowerPoint, review the resources, click on resources, complete the activity, click on the activity, it comes up, and complete the blood worksheet for next day. So this is the blood worksheet. Do you all know how to convert a PDF into a Word document?
Yes, sir, but I get a little trouble with it still.
Still, right. So one of the easy ways to do it, right? Whenever in doubt, you always pop it in Google. Converting a PDF to Word from PDF site. The actually the PDF site has a. I find that's a really good. I'm not seeing it. PDF. But there are a lot of. Right, so look for one from Adobe. This one, it's trusted because these are the guys who actually make PDFs, right? Maybe I'll put the link on this one. And all you have to do is select a file, click on select a file, right? When you click on select a file, it'll tell you convert. Just click on convert and boom, you'll see it come up at the bottom here in terms of the converted file. You don't have to pay for anything. It's done quote unquote free of charge, right? So I like this one a lot. Adobe Acrobat, yeah, online. Because as I said, Adobe is the person who actually make PDF. So there's a very trusted site. All right, so you can have a look at this one in terms of converting it. So for this week, what is required of you is complete the blood worksheet for next class day. So this one, you convert it. Or you could, as it stands here, let me just now. In terms of the blood worksheet, yeah, it's a fillable PDF as it stands here, right? So you could just leave it in PDF format and type in what you have to type in and then just save it. But I know some people like Word. So if it is you do like Word, well, you could convert it, but if not, you could save it as a PDF, all right? And then just have a look at the blood case study. When you finish the blood worksheet and you save it, as the PDF or the Word document, put it into this Dropbox, right? You're all familiar with this in terms of adding it. You have 5 days. It is due on Friday, the 25th of March at 12:01. I'll change this to the 26th. So it'll be due Saturday at 1 minute past midnight on Saturday. All right. And that's it for the week. So all you have to do, as we go through, just look at what students must do, review the lecture, review the resources, complete, and that's it. At the end of today's lecture, what you would see, I will add here below. You'd see the recording and be converted into a YouTube video and placed below. This was usually done within the space of 24 hours. All right, so at the bottom here, you'd see what we did today. Everybody clear so far? Any questions on what is required of you?
Yes, sir. Clear.
Yes, sir. So I have a question, please.
Go ahead, Anessa. And is it yes?
Yeah, in terms of the Miss Brown blood case study, do we have to do that and drop it in as well? What is the date for that one?
No, that's a very good question. Is to do it, we'll discuss that next class day in terms of this blood case study. So this one is not one where you actually have to drop off in the Dropbox itself.
Okay, so just do it and wait to discuss it.
And we'll discuss it next class day, yes.
Okay,
I don't want to hot up all your brain too much though.
Oh yeah, that is a little complicated for me, but I try it. So
yes. So give it a try, but we'll discuss it in class next day. Okay?
Okay.
Great. That's a good point you raised there. Any other questions? All right.
So I have a question.
Go ahead, Charles.
I remember in the last semester we used to do like little multiple choice quizzes at the end of some chapters. But I know that the website wasn't working well and still isn't. So I was wondering if maybe you have found a substitute could help us, because it really helps when we do that little practice.
Okay, I'll have a look and see if I can find any. And if I do, I'll put it up. I'll put it up as well at the bottom down here. Good point. I'll put it up down here.
Great.
I find
Great.
one.
Much.
Okay. All right. Anything else?
Morning, sir.
Go ahead, Kieran.
Morning, sir.
Who's that one? Ernest?
Sir, yeah, Karan, sir.
Oh, Karan, sorry. Go ahead, Karan.
Yes, sir. So concerning the lab class, I know it's starting next month, but I'd like to know that it will be like same time like them to 2.
So the lab class will be starting on the 4th of April, and it's carded to run from 11 to 2. Yeah. What we could do, yeah.
Okay,
so for now, yeah. So 11 to 2, we leave it like that for now. Once it starts, we'll talk more.
Excuse me, sir. So, but I just have to go to work for 2 o'clock in the afternoon. So I am thinking that if it's okay, that I could leave about 1:15.
Yeah, yeah. Because we wouldn't use the way how it's structured, there's time for you to do some of the activities yourself. So would I be here lecturing to you from 11 to 2? No, that wouldn't happen. So we'd usually finish between 12 and 1. We will finish before 1, and there'll be time left over for you to do what is known as self-directed activities. So we will be finished by around 1. So that's not an issue then, Karan, for you, in terms of leaving 1:15. We'll be finished before then.
Thank you, sir.
Good point. All right, anything else? Okay. All right, so today's first day, as I said, I don't want to hurt your head too much. Let's just look over the PowerPoint and then we'd end class, okay? Let's go. So this full lecture, the lecture is already on the website. You just click on, as I mentioned before, if you just click on lecture, you'd see the recorded lecture for the class itself. And this will be so for all the classes. You just have to click on it to see the lecture. So let's go. All right, blood. So is blood important?
Yes, sir.
Yes, that was a facetious question. Yes, it is. Blood is very important. And if we didn't have blood, what would happen? If we didn't have blood, ...
No transportation.
No transportation, it wouldn't exist, right? Because one of the more important functions of blood is, of course, carrying oxygen throughout the body. And why do we need oxygen? 3 words: breakdown. What we need oxygen for? Breakdown.
Energy.
It's for energy, right? And how do we get energy? We get energy from
food, breakdown
food. Yeah, it breaks down food. And that's the only reason why we take in oxygen, to break down food. So we breathe in oxygen, it goes down to our lungs, it diffuses into the blood, and then of course it attaches to the hemoglobin in the form of oxyhemoglobin. So it just attaches to the oxygen, it takes it along to the cells, and then in the cell, what happens? The cell takes up the oxygen, and then you have glycolysis, or the breakdown of sugars occurring in the cell itself. And when you break down cell, so the first portion of glycolysis, which occurs in the cytoplasm, you have the generation of ATP, or energy. And then, of course, some of the byproducts of glycolysis shuttled into the mitochondria, where you have 28 to 32 ATP being generated. All that being said, we need that oxygen to break down food. Sugar is a representation of a simple form of food. So that is why, glycolysis looks at breakdown of sugars. You could also break down proteins and lipids as well in terms of generating energy. So all that being said, that's why we need oxygen to break down food. So what happens if we can't get oxygen into the body? Notwithstanding the fact at the end of it all, speaking to the ancestors, but what happens is that the whole process involving energy generation stops. And that's why, you'll start to feel, if you can't get in oxygen, you'll pass out. Because literally, all of the processes which occur in your body, that is metabolism, breakdown of food, and everything that is done to maintain a constant internal environment. There's a word for that. maintenance of a constant internal environment. It begins with H.
Homeostasis.
It's a long
Homeostasis.
word. Yeah. So all of those things involved with homeostasis would stop. Everything related to all the organ systems will begin to shut down. And when all of those things happen, speaking with the ancestors. So blood, very important. It's a liquid connective tissue. And in terms of what it does, it connects various parts of the body by carrying chemical signals, fluids, and nutrients. It contains certain things very important for blood clotting, right? So one of the important things associated with the blood relates to blood clotting, and that is really important. What would happen if your blood didn't clot? Charles, go ahead.
Oh, so I just wanted to ask a question.
Go ahead.
As we're talking about the blood and the homeostasis. Is this where we also talk about like the positive and negative feedback that happens in the body?
Oh yeah. In fact, yeah, because that's in terms of when you look at if you're hemorrhaging blood, right? The body is alerted to the fact that hemorrhaging is occurring. So it then initiates a set of mechanisms to restrict the hemorrhaging. And on that point, would that be an example of a positive feedback or a negative feedback?
That was my next question, sir.
In terms of hemorrhage, when you're looking at the blood system and hemorrhaging, is that an example of a positive? And why do you think so?
Excuse, sir?
Yes, go ahead.
I would say it's negative feedback.
Why would you say so?
Because your body doesn't want to lose. Okay, I could be wrong. It could be positive because the example you gave us so positive. That one example I remember is when a woman is giving birth. That's the only time the body would respond differently so that the vaginal passage would open up wider so she could actually push out the baby. So in this case, if it is that you're bleeding out, it could really be positive feedback.
And you're quite correct. You're quite correct. It is positive. Yeah. Conflict. In fact, and we'll see it in just a while. You begin a cascade of things to stop it, to stop the hemorrhaging, and also ultimately to initiate things that will lead to the wound healing. But as more blood comes out, you have more and more of the cascade, and we'll see it in just a bit in terms of the cascade, which is responsible for actually blood clotting, right? So that it increases. So in other words, more the blood is there, it causes the body to release more of these things. So it is an example of positive feedback. So do remember that, and I'm glad that Charles highlighted it. These are the two examples, and I'm glad you also mentioned it there. In terms of oxytocin secretion, that's one example of positive, and the other one is hemorrhaging, when hemorrhaging occurs in the body. So those are two of the few examples of positive feedback in the body. All the other mechanisms that occur in the body is really negative, where you have more, you have a decrease in that, which is causing the change. But for positive feedback, to remember those two, hemorrhaging and also release of oxytocin, which causes uterine contraction. Good. Glad you brought that up.
So back to the clotting.
Yes.
So if we're saying that if we don't clot, then we would potentially bleed out, right? Or we wouldn't bleed out.
And that's why hemophilia, that's a disease where some persons do have issues clotting. And that's you just continue hemorrhaging. If you think about it, if you continue you see, we don't think about it really. Are you aware that, during the course of a day, you constantly bursting blood vessels, let's say capillaries, arterioles, really small blood vessels, unless of course you really hit your hand hard and you see a purple bruise. But constantly you keep breaking them whenever you brush against a wall or something. You're not even aware of it, and your body constantly repairs them all the time. So if that did not occur, you would hemorrhage out. All the blood will begin to just leak out into your body. What would that cause? Well, your blood pressure will begin to drop. Your heart will start to beat faster to try to compensate for that loss of blood. And there's more blood coming out, so it's a vicious circle, really. So all that being said, we do have a compensatory mechanism that is very important in terms of that clotting. It stops hemorrhaging from occurring, and by extension, keeps our blood pressure at optimal levels and puts less strain on the heart, which would have to then increase its beating to keep your blood pressure up if you did not have, let's say, a clotting mechanism in place. Yeah. That's okay, Charles?
Oh, yes, sir.
Okay, great. Good question. All right, let's go. So in terms of the blood, the color is red, right? Red. So white is when we look, if you were to quickly look at your wrist, the inside of your wrist, if you look, anybody seeing anything blue particularly? You seeing anything blue or green? In
Yes,
terms of
sir.
the tinge of, so white is, does that mean blood is blue or green?
Deoxygenated blood.
Deoxygenated blood is blue or green. Anybody wants to comment on that? Deoxygenated blood, blue or green? Any comments on that?
No, sir.
No? All right. So let's say if you're in casualty. Okay, so let me ask you this question. So deoxygenated blood is blue or green. Has anybody ever seen outside of your wrist, have you ever seen blue blood or green blood?
No,
No,
sir.
sir.
No. So what does that, right? So what does that tell you? Back to the original question, is blood ever blue or green? Because let's say you get a cut, logically,
I don't think so.
So the thing
I
is
don't
this,
think so.
yeah, what you're looking at is a quote unquote, is an optical illusion in a way. What you're seeing there is a product of the blood going through your veins, that is true, but seen through the wall of the blood vessel and also seen through your skin. So the combination of the wall of the blood vessel plus your skin gives it that green color, green or bluish color. But is blood ever blue or green? Absolutely not. Absolutely not. So if let's say in go ahead. Go ahead.
I say it's either red or dark red, like a
Yeah.
deep red.
Correct. You have different shades, yeah, very dark, or yeah, you have variations in red. So if it is, let's say you're in casualty or whatever, you know, when you do get on the wards and you see somebody get a cut and you see blue blood, what should you do? A 3-letter word that rhymes with bun.
Run, sir, run.
Run. I mean, run and keep running until, you know, you can't stop. Janelle, you have a question? Go ahead.
Yes, sir. Not a question. What I was saying, you say how you said it's an optical illusion. When we were younger in primary school, we used to take the ruler, a clear ruler, and hold it up to the sun, and you'd see the sun looking kind of like different from what it is normally look.
Correct.
So I guess then when you say optical illusion, is something like that. The sun not looking like what you normally see, but because you watch it through the ruler, the view of it looks different from what it really is.
That's an excellent example and an excellent parallel.
Or
yeah.
looking,
so it looks green. Yeah. It looks that color because of the fact your skin is above it and you're seeing it through the blood vessel. It just appears to be green, but it's never actually blue or green. And as I said, if somebody get cut and you see blue blood or green blood, run, because something is terribly wrong and they're not human per se. That's something else, right? So do always remember that. Yeah, your blood isn't blue or green. And I like that example which your colleague just gave there, you know, in terms of sometimes when you look through, let's say, a ruler, the sun appears a different color, right? But so that's an example there of an optical illusion, as it were. But the blood is never green. But mark you know, when I was, sometimes that fact is not hammered home, right? I did at A-levels. I remember up to A-levels, our biology teacher used to be telling us that, you know, that the deoxygenated blood is blue, oxygenated blood is red. The reason why it's represented, if you look in textbooks, you will see it like that, you know, in particular when you look at the circulation related to the heart, which we will do next week. You'll see the diagrams relating to the heart, the deoxygenated blood, let's say returning to the heart via the inferior and superior vena cava. You'll see then they have it in blue, but the oxygenated blood leaving the heart via the aorta, it's in red. And the only reason they do it like that in textbook is for you to get the difference between deoxygenated and oxygenated blood. They use those colors, but it could be misleading. You know, to me, they should put at the bottom, yes, we use blue and red, but do remember, blood is never blue. Blood is never green. Right? We only put it like that so you'd appreciate the fact that the blood returning from the body via the inferior superior vena cava, that's deoxygenated blood, and the one that is leaving, it has returned, you know, from the pulmonary circulation, that's from the lungs, so therefore it's rich in oxygen, and that's why we use red. So they only, in the diagrams in the textbooks, they use blue and red just to tell the difference between blue deoxygenated and oxygenated blood. But in truth and fact, blood is never actually blue. Okay? We good so far?
Yes, sir.
All right, let's go. So blood, right, they have a short lifespan. What's the lifespan of a red blood cell, incidentally? How long does it last?
4 months.
4 months? And how much that is in days?
120 days.
120 days. So that's approximately the lifespan of a red blood cell. And after that, it has to be replaced. Let's go. So some of the things we mentioned in terms of the function, the white blood cells, part of the immune system, very important when we look at the kidneys. The functionality of the kidneys relates to pressure filtration of the blood, and we'll speak more to that when we get to it. Blood is very important for transporting nutrients and waste in the body itself. It transfers heat to the skin surface to be lost. For those of us who actually exercise, I know one of us mentioned that they like exercising and watching exercise videos and so on. When you do exercise, you see that you begin to perspire or sweat, and also vasodilation with the blood vessels close to the skin in terms of losing some of that heat, because muscle contraction, one of the byproducts of muscle contraction is heat. One of the things you have to appreciate, we mentioned the word homeostasis, maintenance of that constant internal environment. What is your core temperature? The body's core temperature, what number is it at?
36.
36.
36 degrees Celsius?
Yes, sir.
Right, so,
Yes, sir.
so your core temperature is at 36. That's a very good average. All right. Now, what happens if you go out of that range? Let's say if you go up to 38 or 39, approaching 40, right? That's a fever. And why is it not good to keep at that temperature? What happens in the body if your temperature keeps going up 40, 41, 42, 43 degrees Celsius? Why does you feel sick? Why does things go wrong? You know, you begin to feel sick and you're lying down, oh, fever,
So
boy.
the only thing I could think about is that the internal environment is too warm. So
It is imbalance, Mr.
There's an imbalance.
It is an
yeah.
imbalance. You're both correct. Janelle, you wanted to add? Go ahead.
I can't say for adults, but I could say for children. Once my son got a fever that ran to 41 and he got a seizure from it.
Yeah. Things could go terribly wrong, you know, as mentioned there. And the reason is this. Remember, when you look at the body is broken up, right? First of all, you know, you start going back to SNF1. We spoke about chemicals. So first you have chemicals. Chemicals then, you know, arranged into compounds. These compounds, they'll find them in the cell itself. And then the cells are arranged into tissues into organs into organ systems. How many organ systems we have again? I forgot. How many organ systems? It's not 12, but 11. Very good. We have 11. So the thing is, so when you look at the body then, what happens when the temperature, we mentioned that 36, that's the optimal temperature. Let's talk a little bit about chemistry. Reactions. For reactions to take place, reactions usually take place at an optimal temperature, right? So in other words, if the temperature goes out of that range, these reactions do not occur. At the level of the cell, we have thousands of reactions occurring, both in the cytoplasm and the different organelles in the cell. So what happens when you go out of that range? What do you think will happen to those reactions? We mentioned one of those reactions today that starts in the cytoplasm of the cell, which is the breakdown of glucose, glycolysis. If you go out of that 36-degree range, what do you think will happen with glycolysis? You know, you have breakdown of sugar, you know, glucose into glucose 6-phosphate to fructose 6 to fructose 1,6-diphosphate to dihydroxyacetone phosphate, and then it ultimately breaks all the way down. What will happen to those reactions?
Excuse me. I think if the body temperature goes out of the regular zone, it should be in.
One word, 4 letters. It rhymes with hop.
It would drop.
Okay, drop is one. I was thinking of another word. On a traffic light, not green or yellow, but
stop, sir, stop.
I thought somebody was going to say red. Yeah, stop. They would stop or they would decrease significantly. And you're very true. So thanks for both of those contributions there. It would stop. So that's why it's critical or drop significantly in terms of efficacy. So if you're looking at the level of a cell in terms of turning out those ATP, those units of energy, it would decrease significantly. And that is why it's very important. When you see fever, fever is a dangerous thing. It is it's dangerous from the perspective, if left unchecked, it could lead to ... speaking with the ancestors. That's why if somebody does present when you get on the wards with fever, it's important to get it down back to that ideal range, right? So those reactions could take place, because if those reactions do not take place, as we mentioned, they will begin, all of the products which are produced will begin to stop or decrease significantly. And if there's energy in the form of ATP, right, person will feel weak, which is why usually when somebody have a fever, you don't see them running around, hey boy, yeah, I have a fever. No, you find they lie down and they, oh, mommy, I am feeling good now, fever. When they touch them, they're roasting like a bake, right? Or a tower, they're on fire. Always important, get the temperature down. Go ahead. Yeah,
Yeah,
Aliyah.
sorry. Just question. You said it will stop. Would it cause any damage to the cell as well?
If left unchecked, yeah. If left unchecked for extended periods of time. However, this is one of the important things, and which is why I like to say your body is a machine. There are mechanisms in the body where if you do have damage to certain, let's say, structures in the body itself, at the level of the cell, even with the organelles, they'll be replaced. So for instance, what organelle do we have? So if you have an organelle, let's say we're looking at some part of the cell, and let's look at the mitochondria. For some odd reason, temperature go too high, mitochondria kick out, and you have some of the mitochondria dying. We have another structure in the cell that will destroy or take it apart. Which organelle is that one at the level of the cell that will destroy then? Lysosome, very good.
Lysosome, sorry.
Yeah, quite right. So the lysosome then, if it is the mitochondria kick out, boom, it will go inside and destroy them, because it don't make sense just having dead mitochondria around. Notwithstanding that, signals are then sent, hello, we need some more mitochondria, and then you would have genesis of the genesis or the making of other mitochondria by the nucleus. So signals then are sent to the nucleus. Remember, in the nucleus, you have all the instructions for everything. So you also have the instructions of how to make mitochondria. The signal is sent, and then you would have the reconstruction of new mitochondria. So that's something to remember, to take note of. Your body does have mechanisms such that if you do have certain organelles which have been displaced or destroyed, because of the excessive amount of heat, they will be replaced. And that's why I say the body is fantastic. We're talking about on the level of a cell, we're talking micrometers in size. It has all of these checks and balances in it. And by extension, the cells, cells, tissues, organs. However, you do have some structures in which this cannot occur, right, as it relates to the organs. And that's why you do have organ failure occurring if, for some odd reason, you have cell destruction. When we look at the liver, the hepatocytes, the cells that make up the liver themselves, they do have this regenerative ability, the ability to regenerate if you do have damage from, let's say, high alcohol consumption. And in fact, when you hear somebody has cirrhosis of the liver or destruction of the liver, that means is more than 50%. Notwithstanding the fact that the liver could regenerate the cells, if you destroy up to 50% of your liver could still actually work. When you hear somebody has cirrhosis and the liver is not functioning, I mean more than half of the liver is gone, right? So do remember, yes, your body does have regenerative properties. There are some organs that have better regenerative properties than others. Key among them is the liver, right? The heart is actually, it doesn't have a lot, which is really incredible. The heart actually keeps its cells. It doesn't break down very easily, which is why you don't see cancer of the heart, for instance. You have cancer of all the other organs except the heart itself. The heart is very good at keeping itself in check in terms of preventing cancer from occurring. We'll talk about that when we speak more to the heart itself. But yes, when you go out of range as it relates to temperature, it could lead to the cell destruction, which could lead to tissue damage. But the body does have, it tries to repair it. And as I mentioned with the liver is the best example of an organ in terms of repairing. But for cirrhosis of the liver, usually destruction in the liver coming about from, let's say, excessive alcohol consumption. It could lead to permanent liver damage in certain instances. Okay, we good?
Yes, sir.
All right.
Yes, sir.
All right, let's go. So components of the blood, of course, you have the red and white cells. You have different here. Yeah, you have the white cells, different parts, very important. And then you have the red blood cells, the plasma or the water. Very important protein in the blood is albumin. Have you heard that word albumin before? Where have you heard the word albumin? In the kitchen, for all the bakers. Well, talk to me about albumin.
In the egg.
Right, so the yellow part of the egg is called the
Albumin.
The yolk. The white part of the egg is albumin. Okay, that was just a little J-O-K-E joke, just as Y-O-L-K is yolk. Yeah, the yellow part is the yolk. The white part is the albumin. So, and why do you use, so one of the things you will appreciate, sometimes blood, when you smell it, it smells fresh, yeah? Kind of like egg. And the reason why is because it's smelling the albumin. What is the blood, what do you use albumin for? I'll give you a hint. The albumin is very much like a vehicle that is on the road that rhymes with taxi.
Transport.
4 letters, same 4 letters. Transport, thank you very much, Bina. Yeah, so albumin is a transport protein. So when you need to move things around, yeah, albumin, it's a protein. It will latch it on. It will latch on to whatever needs to be moved and carry it where it needs to be going. So at this level, just appreciate albumin is a carrier protein. Very, very important, because without it, then things wouldn't be able to move around in the blood to specific areas, okay? So components, this just shows the different components and how you would see it. If we were in the live lab, you know, we'd actually take these things. Question, you all are aware that all the labs will be online, yes? I should have clarified that. Everybody knows that?
Yes, sir.
Yes, sir.
Yeah, let me make that point clear. Because some,
yes.
Yeah, so all the labs, unless other dictates, and I don't think they'll change it mid-semester, no. So for now, in terms of the mandate we have received from the ministry, we will be online for this semester. So both the lecture and lab, unless we receive a different directive, which I don't think we will be receiving because we have already started, for the rest of the semester, everything will be online. All right, just to clarify that. Let's go. So we'd look more at this when we actually doing the lab, right? We look at some some examples of blood cells. So this is just an example here of the different types. You'll be well placed to have a look at the different blood types and what they look like in terms of the structure. But we'll speak more to that when we look at the lab. So the major portion of the blood, we have water, protein, right? 90% is water. So which is why it's important. I'm sure my friend there who mentioned she likes to exercise could attest to that, that do consume water, right? It's important to drink water. Other than drinking, where else, what other source, where else do we get water from on a daily basis other than drinking it straight up?
Like from fruits?
Yeah, from the food you eat, quite right, very good, yeah. So do remember to keep your water levels up, all right? So plasma, we spoke about this, which is why it's the most abundant of all the proteins, albumin. It's a carrier protein, very important for carrying things around in the blood itself. Hematopoiesis, right? So this refers to the differentiation, hematopoiesis, or the formation of blood cells from the stem cells, hematopoietic stem cells. And this is, where would you find these hematopoietic stem cells? Where do you think? It's part of your bone. What part of the bone?
Bone in the marrow.
In the marrow, very good, yeah. So you'd find these stem cells in your bone marrow, right? And from these stem cells, you have the formation of different types of blood cells from those hematopoietic stem cells, right? So this is just showing a disease, leukocyte, normal blood. What difference could you see between the normal blood and somebody with leukemia? Somebody talk to me about the differences you see. This is normal.
The
color, yes. Okay, the color, yes, the color is a little different. What else? So you trust in your eyes.
The shape of it.
The shape
you can't really tell that it's a neutrophil or a lymphocyte.
I hear what you're saying. Yes, yes. You know, so in this case, here we are seeing a leukocyte, and they're looking at, well, we don't have an example here of a normal leukocyte, but they're looking at it, they do look a little different, right? So they look a little weird, as it were. Anything else?
Excuse, sir.
Yes.
It seems as though the bigger red bloods have like a kind of film around it.
Yeah. So what is that? What that represents is the staining of the cell membrane. Yeah. So that is it there. So what we're looking at, this huge part here, this is the nucleus, and around it, the darkened part there, that is actually the cell membrane, and the cytoplasm will be this little, the area shown here. So all of that, you're quite right. It has this like a film around it. That's the cytoplasm, and the darker area to the extreme there, that is the cell's membrane. So this dark part here is really the nucleus, and you can see it's very large. And this is how it looks with a patient with leukemia. And what about the numbers? Look at this sample and look at this sample.
So I've seen something here on the patient with the leukemia. The cells seem more clustered in certain places.
Yeah. Right. And what about the representation of the red blood cell, the numbers? What could you say?
It seems want to look more.
Yeah, in this one, the numbers here of the red blood cells are larger. But here, these are the malignant ones. So malignancy speaks to cancer, right? So the cancer cells are more numerous when compared to the other cells, relatively speaking. So in this sample, for instance, I don't know what volume of blood this is, but it looks comparative. We have a large number of red blood cells, but with a patient with leukemia, the number of red blood cells, relatively speaking, are less when compared to the other types. So in this case, the malignant leukocytes, we have quite a large number of them. Whereas in this sample, if you notice, just have a few other type of cells, notwithstanding the red cells, neutrophils, and the lymphocytes. Right? We only have 2 of them, whereas here we have about 10 of these other types, the malignant leukocytes. Good. So what does a red blood cell look like? It's small, it's chunky, right? It's approximately 8.4 micrometers across. How big is 8.4 micrometers? Somebody tell me, break it down. How big is 1 millimeter?
So I think last class you had told us put your index finger and your thumb finger together. And just as you're trying to pull it apart, that little space you're seeing, I believe that is the representation.
Of a millimeter. That is 1 millimeter. Right? So quite right. Thank you for sharing that. Imagine, put your thumb and your forefinger together and just take it apart. When you now start to see light between them, that is 1 millimeter. Now take that 1 millimeter space, divide it into 1,000. And that is 1 micrometer. So if you could imagine that little space, 1,000th of that space is a micrometer. And this is just 8 micrometers across. So it's real small. And the other question is, in a liter, let's talk about how many of these then we have in a liter of blood. How much do you think, based on that? You think it's a little bit or it's plenty?
Plenty.
And okay, anybody wants to make a guess? How many red blood cells we have in 1 liter of blood?
Millions?
Millions, okay, that's a really good guess, yeah. But we need to pump that. About how many million you think?
I'll go with 5.
With 5. So, sorry, I said liter. I really should have broke it down to microliter since we're looking at this. Per microliter. So per microliter, if you were to imagine, on average, we have 5 million red blood cells per microliter. So to get it then to milliliter, you have to multiply by 1,000. So you have 5,000 million per milliliter. So to get it to liter, you have to multiply that again by another 1,000. So 5,000,000, which is 5,000 billion, right? Which is a trillion, 5,000 billion. Yeah. So you have 5 trillion red blood cells per liter of blood. And why it is you have so many red blood cells? That's a lot, 5 trillion per liter. Why does you have so many red blood cells? Usually in your body, when you have a lot, you see something, and we see this when we look at reproduction in terms of sperm cells. You have this whole lot of sperm cells. Why it is you have so many? Usually when you have a lot of things, it's because it is a word that rhymes with brimportant.
I would say disposable.
It is disposable, yes. And therefore, it also points to the fact that it is, or the functions associated with it is very important, yeah. And you're quite right when you say disposable. So you make a lot just in case something goes wrong, so you could replace them. Quite right. Right, so similarly with
I was about to say that, well, I'm thinking that we would have so much because, you know, it's not just one function the body doing, but doing several different things at once. So you could need that much to get everything working.
Correct. And that is why, coming back to the term important, it has, as we just looked at, you have a lot of different things occurring with blood and function of what it does. So therefore, blood is important. So therefore, in terms of the carriage of oxygen, very important, because what? Oxygen carriage relates to formation of energy, really important. So what do? That's why we have 5 trillion red blood cells per liter, because it is so important. So in case something goes wrong with a couple 100,000, with 1 million, that's all right. We still have a whole lot. So usually in the body, when you see that for something, a function, and you have a whole lot of cells associated with it, it points to the fact, as Charles said, that it is important, that it could be then that there are a lot of functionalities associated with it. And also, as was it Janelle also mentioned, right, it's very important that you have it in the event something goes wrong with a couple of them. Right, so you still have what is known as quote unquote backup. You have a backup plan, a plan B. All right, so if a couple of 100,000 of them gone, all right, we could still work. Even in a disease state, when you look at persons who have leukemia, right, even though the blood is not working optimally in terms of its function, it still works. And the reason why it still works is because you have so many of these cells around. Yeah. Okay, we good?
Yes, sir.
Now, we're looking at the red blood cell, right? So here it is, it's composed of proteins, hemoglobin. So these are proteins. And also, we notice mixed up with these protein are these little discs of iron. And one of the things we have to remember as it relates to red blood cells, for red blood cells to function properly, it is critical that it has iron in it. And what happens, or what state is recognized when you don't have enough iron? What state do you go into when you don't have sufficient iron? Anemia. You become anemic. All right. And is there a way to quote unquote increase the amount of iron if it is you're anemic? Right, either for women, heavy menstrual flows, you could lose a lot of iron that way in terms of blood loss, or it is your diet doesn't have it. Could you think of some foods that have a lot of iron? Let me hear some new voices. Thanks very much. Spinach, beetroot, yes. Anything else?
Dashing bush.
Anything else?
So I've heard that sorrel helps build it up.
Sorrel, interestingly enough, sorrel is also good for what other, interestingly enough, if I were to tell you sorrel is related to cranberries, it's actually in the same family. What do you think sorrel is good for? It's another organ system it affects then. And it
urinary system.
Ooh, yeah, you hit the nail on the head. Yeah. So all that being, so do keep that in mind, if it is you have a urinary tract infection, drinking sorrel is actually quite good for it, right? So sorrel is in fact, I'll get the paper to show you, sorrel is more efficient than cranberry in terms of dealing with urinary tract infection. Urinary tract infections. Yeah, it's very, very good for that, urinary tract infection. Right? And it's something that is not highly publicized at all. But we quick to go and get cranberry juice, which costs an arm and a leg, But you could use sorrel in terms of urinary tract infections. Drink it. It's very good for that. All right. Okay, good. So hemoglobin, iron. So we spoke about foods rich in iron. Right, dashing bush, green. I have seen papers mention green fig is also good in high in iron. So green leafy vegetables in general, those things. Liver is a rich source of iron, quite so. And how you cook liver? Let me hear you.
So I do eat it, so I don't know how to cook it. Well, normally they go curry it and put it just like your gizzard and thing, I believe.
Yeah.
Curry, and I know some people there's butter it and fry it.
Yeah, but you hit the nail on the head. You see me and chicken liver. In fact, when I was in grad school, I always remember that was something I used to look forward to. The churches over in Atlanta, churches chicken, they had on the menu liver, right? Fried liver. And they would do it fresh because, if it stays, liver gets grainy, right? The consistency changes if it gets cold. So they used to do it on order. And that was something I used to look forward to getting. So they'd batter the as you rightly say, the liver and fry it for just about 2 minutes, not very long, because if you fry it too long, it gets hard. And then, a liver and fries, making joke with a biscuit. Oh, you're bringing me back. All right. Yeah, but chicken liver. But you're right. It's either you like it, chicken liver or liver in general. Something is either you like or you don't like. It's an acquired taste in some instances. I digress. Let's get back on the topic. So we spoke about the red blood cells. Now the white blood cells, of course, very important for the immune system. And we'll speak more to that later on. Inflammation. Inflammation is the body's response to injury. Right? Erythrocytes, we mentioned the red blood cells. Right here you have about 5 million, as we mentioned before, per microliter, and that translates to 5 trillion per liter. And the reason why, because it's very important. So this is just showing erythrocyte life cycle in terms of how it's made, and we mentioned the homeopoietic stem cells present in the bone marrow. They are able then to make these red blood cells themselves. Erythropoietin, interestingly enough, what happens in instances if we go in areas that have low amounts of oxygen, let's say to the top of a mountain or really high up in the air, Let's say, now, when we say top of a mountain, we're not talking San Fernando Hill or Paramin, right? We're talking really high up, right? Or Mount Hololo, we're talking higher than that. When you go up, as you go higher, what happens to the concentration of oxygen in the atmosphere? As you go up, would it increase or decrease the amount of oxygen?
It decreases.
It decreases, yeah, it decreases significantly.
The red blood cells increases in the body as a
result. And how does it do it? Remember, I told you the body is a machine. How does it do it? Well, your body recognizes there are sensors in your body. So as it goes up, as you go up, you get in trouble to breathe. You find you're sucking in and you're still feeling like, hey boy, I'm feeling tired. What is happening is the concentration of oxygen is decreasing. You have sensors in your body that detects it, and it then stimulates the kidneys to secrete this substance called erythropoietin. And what erythropoietin does is it stimulates the hemopoietic stem cells in the red bone marrow. It tells them, hey, we need to produce more red blood cells. So these more red blood cells now are produced. And even though there's less oxygen, when you have more of these red blood cells, you're able to grab more of the oxygen that is available. So in so doing, in producing more red blood cells, that then corrects the situation. Right? So very importantly, when you go up, so what some people do, interestingly, there's something called blood doping. And you could look it up, for yourself, blood doping, but to be in a nutshell, if you have a race, right? And let's say the race is next week, and what would you do? Some persons, they would go then to a high altitude area, let's say in Peru, let's say so they go up in the mountains and to train. So what happens is, up there is very high altitude. So what happens, the body then recognizes a high altitude, we're having a problem with oxygen, so it produces a lot of red blood cells. Then what would they do? They would take out that blood and store it. That blood, of course, has now a high oxygen carrying capacity. Because of the fact it has so much, the concentration of the red blood cells would be higher than the usual 5 trillion per liter, right? It's much higher than that. So they store their blood, take out, I don't know how much, but they take it out and they store it. So now, let's say they come back down, and the race is tomorrow, I don't know when, but they'll take a blood transfusion of their own blood. Right, so they take the transfusion of their own blood, and now when they go to run a race, they now have a greater oxygen carrying capacity. Anybody here ever run races in school, or anybody, or we have any athletes here?
Yes, sir.
Right, you'd recognize that one of the things, you come to a point when your legs, they start to ball at you. Oh God,
yes, sir.
I'm running out of oxygen, I can't, no more.
Yes, I have to breathe harder.
You start to breathe, and your legs, they start to hurt. And that is because it's running out of oxygen. So you could circumvent that problem. If it is now, your blood has a lot of these red blood cells and it's carrying now, has the ability to carry a lot more. What you'd realize is that burn you get in your legs, it will stop. So that is known as blood doping. Or hitting the wall. Thanks, Janelle. Yeah. Right, runner's wall. Go ahead.
So it wasn't a cyclist charged for that same blood doping. I was trying to find out exactly how it worked, but I mean, you did explain it. So yeah.
Okay, no
I
problem.
Heard about it.
Yeah.
I believe it was Lance Armstrong.
Yes. Oh gosh, you hurt me when you say that, because I used to admire him so greatly. And then,
I was shocked too.
I actually have, he wrote an autobiography. It's not about the bike. I have it there, and I was like, this, because with him, he had testicular cancer. So actually they removed his testes, right? Before they removed the testes, he stored some of his sperm so that afterwards, he got married and so on. He was still able to have children from the stored sperm, and, I used to be admiring this man. Oh, this man is so good. Not only did he do blood doping, he took some banned substances that actually increased his oxygen carrying capacity. So he went even beyond this erythropoietin. He went a step beyond. Yeah, wow. So, and they caught him. Yeah, and now there's the thing. How they caught him, clearly he angered somebody really bad, right? Because this is how they caught him. All before, they used to be testing him all the time because he won the Tour de France. The Tour de France is a ridiculous race held over a period of it's like 2 weeks, where you're going up the mountains of France and the Pyrenees, across Europe. It is very grueling. And he won it for like 6 times in a row. And they would keep testing his blood for drugs because they were almost certain that, this guy doping, and they couldn't find anything. And it so happened, as I said, people within his group, somebody took a sample of the drug and they sent it to the FDA anonymously and say, look for this in Armstrong blood.
Wow.
And that's how they caught him. Yeah, because all the time they couldn't, it was a drug, a synthetic drug that they did not know about. Right. Somebody in his group, like as I say, he probably didn't. They send the sample to the FDA, and that's how they caught him. Other than that, they wouldn't have catch him at all. But he was using illegal drugs, notwithstanding erythropoietin. It was in other words, than probably erythropoietin on steroids. They found another drug that worked even more efficiently than erythropoietin, and he was using it. And for years they didn't know about it until somebody within his group, sent it to it, and they said, check, look for this drug, and that's how they caught him. Yeah, but Lance Armstrong, yeah, he's hot me still to this day. Okay, let's go forward. Thank you. So we mentioned anemia. As we mentioned, the causes of anemia, these are some of the causes there, and you have the different type. You have hemorrhagic and you have production failure, as we mentioned, due to iron deficiency. This is polycythemia. Anemia is a lack. Polycythemia is too much red blood cells, as shown here. This is an example of sickle cell anemia, which disproportionately affects persons of African descent, right? And my understanding, it's quite painful. They do have episodes where these sickle cells actually stick in the the capillaries and the arterioles, and it's very, very painful. Right? Platelets, very important for formation of clots. Thrombopoietin. Thrombopoietin refers to the body's reaction to hemorrhage and subsequent healing. Right, so this is thrombopoietin, and thrombopoiesis is, of course, forming of a blood clot. Right, so hemostasis, the control of the hemorrhage, and homeostasis, the maintenance. Yeah, so do remember those two, hemostasis, right? Very importantly, the control of the hemorrhage, which involves forming of the clot and also the healing that occurs afterwards. So this is as shown in terms of the formation of the clot and the healing, subsequent healing. Significant blood loss is associated with low oxygen transport capacity and a low blood flow. This is a very important pathway to look at, the coagulation pathway. We'll speak more to it in detail when we look at the lab. But all that being said, when you do have some disruption to the blood vessel, this is showing what happens. So you have then, when you have the blood vessel disrupted, some factors on the outside of the vessel, they are activated, factor 7, activated factor 7. Normally it's inactive on the outside, but when in combination with some of the substance that comes out, it's activated. And this substance, which is a chemical, it then leads to the activation of thrombokinase. Activated thrombokinase then acts on another protein, prothrombin, converting it into thrombin. Thrombin then acts on fibrinogen, another protein, to form fibrin. And fibrin are these fibers that actually trap the red blood cells, very much like a net catching fish. And the fish happen to be the red blood cells in this case. And that is how you form a clot. But all of these things, this cascade of reaction involving all of these proteins is initiated when you have this leakage or the breakage in the blood vessel wall. That leads to the activation of factor 7. And factor 7 then begins this cascade activating thrombokinase. And then this activates prothrombin, converting it to thrombin. Thrombin then acts on fibrinogen, converting it into fibrin. And this forms a mesh, catching the red blood cells here and stopping the blood flow. So now you'll have a clot forming. Very interesting, right? A clot is a weave of fibrin at the site, and thrombosis is an abnormal, localized, invascular collection of platelets, right? So do take note in terms of the difference of these two, a clot and a thrombosis. Right, transfusion, this is the last thing we'll look at in terms of blood type. Right, type A, B, and O. We'll speak more to this in the lab itself. And in terms of these, which ones you could receive, I'll show you all of, I think it's in the notes, but if not, I'll show you a very nice way of remembering it. Let me just, there's a very nice site. When you do have the this blood typing game by the Nobel Prize, after you go through your notes, it's a very nice site to look at in terms of blood typing, right? So play this game, and let's see if we could actually. Yeah, there's a nice, there's a very simple diagram. Here it is. All right. So what does this tell you? Well, it tells you okay, yeah, okay. I don't want all the drama. You just leave this one up. So let's do this. Okay. Right. So what this tells you, all right, you all still there? We're almost done. Next.
Well, yes, sir.
Yes,
7
sir.
minutes, we're finishing. What it tells you in terms of donors, who could give to whom. So this says blood type O could give to B, O could give to A, O could give to AB. So therefore blood type O and its P could give to M. Positive could give to negative. Right, that's another part to remember. Peter, and I didn't write it here, but positive could give to negative. So therefore, O positive, therefore, is known as positive could give to negative, but negative can't give to positive. So blood type O positive is known as what? The universal donor or recipient. If it could give to AB, what is it known as? Universal donor. Right. And in terms of recipient, AB positive is known as the universal recipient. Yeah, because it can receive from everybody. If you notice, tooth bag I, B, A, and positive. Do remember that positive could give to negative. Sorry, I said backwards. I apologize. It's NP, not PN. Negative could give to positive. Positive cannot give to negative. Found a song in strain. So therefore, O negative is the universal donor, and AB negative, yeah, negative could give to positive, but positive can't give to negative. Yeah, AB negative is the universal recipient. Let's look at this now as it relates to this blood typing game. Yeah, O negative. All right. Patient has been in an accident and needs a blood transfusion. First, collect a blood sample, right? So you're in Port Spain General, San Fernando, Scarborough, Point Fortin, Eric Williams Medical Sciences, Complex Mount Hope, right? You need a blood sample. So you take it. Then what you do? You do the blood typing, right? So let's put it, when you have the formation of a clot, sorry, not a clot, the formation of, or the agglutination, that's the word, within the sample solution, that means it is that type. So we have nothing here. If you have nothing, it remains here. So here you have this agglutination. So we know this has B in it. And the rhesus factor is there. So you have a positive reaction. So what blood type you think this is then? You have positive rhesus. Rhesus is either positive or negative. And here you have it B. So we know it's a type of B. And since we get a positive reaction, we know it's B, positive blood. Everybody good with that, or you want me to go over that again?
Yes, sir, run that again.
Run, no problem. All right, let's go again. So what they do, it probably load up a different scenario. And what are we doing? Let me just take a step back. This website is excellent, Nobel Prize website is the most phenomenal website, I think. Yeah, that's what I was telling you. Negative could give to positive, but positive can't go to negative. Right, our biosystem, it speaks to that. But one of the good things about this site, before you even, let's say, do the game, and this will be the last thing we look at. you could click on learn the theory and it tells you about blood types, how to find it and perform. I would strongly suggest you look through these, yeah, before you actually do it. It's some really good background information.
Excuse me.
Go
I
ahead.
didn't know it was B negative. And
Okay, very good. Let's have a look, see. It was B positive, the one I looked at just now. But let's look at an example and let's see if we can clear it up. So in terms of how do they know what blood type you have? And they have this solution. This is actually how they do it. They have different ways of doing it. Sometimes, as you see over here, they rub it. You have this solution embedded in the paper, so you can just put the blood in and see if you get a reaction. If you get a reaction, so you have three solutions, one with A, B, and one that detects the rhesus factor. If you get a reaction, you'd see agglutination happening. Agglutination, long story short, you see a ball forming at the bottom. So if you see a ball, that means yes, okay, it has A in it. Remember, in terms of the blood types, you have A, B, and AB. So if you get a reaction with A and B, you know the blood type is AB. If you get a reaction alone with A, it's blood type A. B alone, blood type B. And this one, rhesus factor, is positive or negative. If you get a ball, it's positive. If you get no ball and everything turns red, a negative reaction is when the whole solution turns red. So if the solution turns red, I mean it's not A. Solution turns red is not B. Solution turns red, that means it's negative. We good? Let me say that one more time. Okay, good. So let's see. I wouldn't say nothing, and you tell me what it is. All right. So is A, does it have A in it?
Yes, sir.
The blood type, yeah. Does it have B?
No, sir.
No, because everything turned red. Does it have rhesus factor positive? Is this a positive reaction?
Yes, sir.
So therefore, what is it? A?
Positive.
A positive.
We good? And
Yes,
that's how you
sir.
figure it out. Y'all do a next one, or you do a next one just to check the blood type, just to make sure. Now you could visit this site for yourself, and play with it as much as possible.
So right, question.
Go ahead.
O positive.
O positive?
Yeah.
You didn't see it? That's a good question. You would get
because
negative.
Nothing will come up with A and B?
Correct. Very good. And I like your deduction. Yeah, you'll get nothing. So if you get, I didn't mention that. I'm glad I did. If you get nothing in A, nothing in B. So if both A and B turn red, it's O. It's O.
Okay, thanks.
I didn't mention that. That's a very good. I'm glad you brought it up. All right. So here we're going again, taking out some blood. I stay in quiet. You all tell me which type is this one. All right, which one do you think this is?
Negative B.
B positive.
When you do see with the rhesus, right? So when with the rhesus, once you see this little ball, the ball means it's positive. If the solution was red, I mean it's negative. Sorry, I couldn't write on it how to write. So ball, positive, red, the whole solution red, negative. So based on that, what is this thing here? Is it B positive or negative? B positive. That's okay?
Yes, sir.
Yeah. All right,
so super important question.
Go ahead.
The group chat. We didn't talk about that.
Oh, a group chat. Could somebody do that? Well, we could do that in the end. We could, somebody just do up a WhatsApp group, and I'll just speak to the WhatsApp group. If you could add me, I will. Now the WhatsApp group is outside of COSTAT's purview. So therefore, and I give you my word on this, I wouldn't quote you on anything you say there. I can't correct you. Hey, what's that you talking? Hey, anything public? No, I cannot do that. I will just be there so that if you have any information or you want to contact me or speak to me or ask questions, that's what I'm there for. So I'll just be a participant, and you could, and I will not be exercising any of my teacher, responsibilities there. All right. So somebody wants to take up that in terms of making the group, the WhatsApp group. Your responsibility on that one?
Yes, sir. I would do it.
Okay, great. Excellent. Thanks a lot. Well, yeah, I want to say I have my number already. Yes. I gave out my number, I think, from the last grouping. Or if not, 754. What's my number again? Phone number. Oh, I don't know how you'll do it. How you'd set it up. You'd want numbers or you'd send it, put it in the chat, in the you could put it actually in the
Yes, sir. I'm gonna put it in the chat
WhatsApp.
now, the link, so everybody
Yeah.
could just join with the link.
Yeah, that's best. Excellent. Okay, so let's continue here. So this one has blood type B positive. So you need 3 bags of blood. So if you're B positive, where you could get blood from? That's okay. B could get from where? Now, one of the things you could, when you're a certain blood type, you could get it from either one of the sure sources is the same type. Yeah. So if somebody is B positive, which one we definitely know will work?
Oh.
B positive. Yeah. In terms of the transfusion. Right? Because it's the same type of blood, right? So let's see if B positive will work. Yeah. Oh, sorry, I picked up the wrong one. Look, B positive here. You know, if you're B positive, it stands to reason then that you could get blood from B positive. That makes sense? If you're B positive.
Yes, sir. That makes sense.
Yes, sir. That you're getting the same type, you know, the same type of blood. Yeah. Good. So B positive, that's one. Where else could he get blood from? O. Will it be negative or positive?
Negative.
Right? Because how I always remember it is NP, you know, like gas. Negative could give to positive, but positive cannot give to negative. So O negative. Where we have O negative, we generate some more bands. I'm not seeing O negative. Generate more bands.
Okay, so could you repeat your number one more time for me?
Oh, my WhatsApp number. Hang on. I just never remember it. I just had to look it up. If you don't mind. Mm-hmm. 266-8770.
Okay, thanks. I'm gonna add you now.
Right, no problem. Right, and you don't have to put me as no administrator, but just put me as a normal, because I just a normal observer. I see it in the chat there. Okay, so back to this one. Could we give him A positive blood?
No, sir.
No, because when you look at this diagram, if you notice no arrow going from A to B, only where the arrows is going. So A could give to AB, B could give to AB, O could give to AB, but it does not, A can't give to B, B can't give to A, right? So do take note of that. So this person is B positive. So the only, as we mentioned, O negative or B positive, those are the only. So here we have a O negative. Let's see, right? And we said, what was the other one? Here's another O negative. Right? So as I said, do play around with this. We'd go more into detail with this when we're in the lab. All right? But this little diagram here, to me, is always good to draw it because it helps you remember very easily, you know, in terms of donor, where donor is concerned. Okay? We good?
Excuse, sir.
Yes, go ahead.
So you say look at the arrows, right? But no arrows lead to O. So who could give O blood? Only O.
Ah, good question on the floor. No arrows given to O. So who could give to O? Anybody want to answer that? Actually, you answer the question yourself. Very good. Yeah, and that is why it's a bit of a curse. If you're, you know, if you're O negative, yes, you know, you could give to everybody, but the thing is, yeah, you could only get from O negative. Quite right. Very good deduction. That is very good deductive logic you use there. Yeah, so if you're O negative, if you're O positive, you could only get from O positive or O negative, full stop. Right? Whereas with these, you know, for instance, here, you could get from A negative or you could get from O negative, right? Same thing for B and same thing for, well, for B you could get from O negative or B, well, whichever B type you are. And similarly for here, you could get from O negative and whichever AB type you are, and also from B and A negative and B negative. But if you're O, that's a very good question, very good deduction, yeah?
So O negative only could receive from O negative.
Correct.
And O positive could receive from O positive
Correct.
and negative.
No, remember,
The hardest one actually is the O negative.
Negative could give to positive. Oh yeah, yes, you're correct. So if you're O positive, you could get from O negative or O positive. You're quite right.
Yeah.
Correct. So yeah, the hardest one based on statistics here is if you're O negative.
The negative, yes.
Yeah, that's the one that has, you could only get from O negative.
So the reason why I had asked is because my mom is a blood donor, right? And since we're small, she would always sing it in her ear that she's O negative. So I'm guessing the reason for that was that
it's a rare type.
In case anything happens, she could only get O.
Yeah, O negative specifically. If she's O negative, she could only get O negative. That's the only type of blood. But by the same token, she could give to anybody, you know. So it's a highly sought after blood type, if you understand. So if anybody get in any accident or anything, O negative is the type. If you have O negative blood, you could go and donate. Full stop, and they could use it. And that's why it's known as a universal donor, O negative blood. Right?
So how much you're paying?
I kid you not. It's very, very rare. Right? And it's a highly sought after one because, you know, anybody could use it. So it's in demand. And in fact, some people, I know for a fact, they do sell blood. Over in the States, is actually a whole industry on that. I don't know if you're aware of it, right? Where you could go and sell blood, and people do that, you know, when times hard.
I have to look into that, sir.
Yeah. And
I'm O positive.
Over there. Oh,
I'm
you're
O positive.
What you saying?
Yeah, I do donate. I donate before my daughter. I donate about 3 times.
And I'm sure they smile when they see you.
Of course, they do for me. But after surgery with my daughter, 3 years now, I still have to contemplate to go back because, you know, it takes a lot out of you when you donate. So I have to decide on that still. But I do. I did donate 3 times already. So I will continue though because I'm O positive.
Yeah. So that is very, very good. O positive. Wow. So here it is. How much? So they don't, you know, they say you can't make money off of it, but they give you $50 to $75. You know, it's tomato. They give you $50 to $75 per appointment. I know a lot of homeless people, for instance, they do that in terms of, because if you're, you know, things tight, what you'll do, they go and they give blood. Once they're clean, they do test you, and you could give blood, donate blood. Of course, even what some people do, which is at risk to themselves, you know, they'll ask you when last, you know, you gave blood or whatever, and they wouldn't exactly tell the truth because the network isn't, the information isn't like, you know, all the plasma centers are online, so they could check on it. But I know people over there, and in fact, people in college and so on, when money tight, yeah, you go and you give plasma. There are companies that will buy your blood, and, you know, by extension, your plasma, they use the blood plasma. Right, here it is, some examples, PPL. So you go in and, yeah, give a blood donation, and they will quote unquote buy it from you. All right. Okay, so we'll stop there for today. Let me just stop the recording. So what did we look at? Well, we did an introduction, you know, where everybody spoke about what they did, different things they like to do and so on. And then we spoke about the class web page itself, what is required of you per week in terms of going through the website and clicking on the requirements for the week itself. And we spoke briefly about blood, by extension, you know, the different things associated with it. We mentioned, of course, importantly, notwithstanding the information stored on the recording, but we mentioned importantly about how an example of positive feedback is the whole process of blood clotting, an example of positive feedback. And next to the secretion of oxytocin necessary for uterine contraction during pregnancy, delivery, that is two of the standout example of positive feedback mechanisms in the body itself. We look at the different things associated with blood in terms of the functionality, its ability to carry different waste products and also oxygen throughout the body. Oxygen is needed for the proper breakdown of food to generate energy in the form of ATP. Mention as well importance of keeping that body temperature within that 36-degree range. Very important because of the fact these reactions take place at this specific temperature. Going outside of that will affect those reactions, and therefore they will stop or be markedly decreased. So that's the importance of keeping that. Mention different types of blood, the white blood cells, red blood cells, mention that. Mention the erythropoietin. When you have a lack of red blood cells and you go up in terms of in the atmosphere, either climbing a very high mountain where the concentration of oxygen is decreased, you now have the secretion of erythropoietin in terms of the hormone from the kidney, causing the hematopoietic stem cells in the bone marrow to now produce more red blood cells. This could lead to blood doping. And we also went and mentioned our good friend Lance Armstrong and his Tour de France victories. All of them were revoked actually. Right? When they did find out about the doping, they took away all of his winning, those Tour de France, the 6 or 7 wins he had, they removed them. Yeah. So the last thing we mentioned, of course, is blood typing. We played this game, and I would encourage you as well to play it. It's a nice way to reinforce your knowledge on it. Notwithstanding that, there's very good information concerning blood typing. We'll speak more to that when we get into the lab. Let me just stop the recording now.